Bridge bearings. When you do your maths on a bridge, we say this is a fixed bearing, this is a roller bearing, a removable bearing, a floating bearing. But what is a bridge bearing? A bearing is designed to obviously hold up the weight of the bridge to bear the weight of the bridge. Let's have a look at the basic layout of design of a few types. This is a modern one. This is a pot bearing. That polyurethane disc is attached to a plate above that I've removed for convenience. Goes in a pot. The entire bridge is sitting on that polyurethane rubber block. High strength polyurethane rubber block. And it's sitting above, let me just draw them in clearly. That is the outside of this. That is the outside. So that's your base of the pot. That's the top polyurethane block. That's a pot bearing. Simply, that pot does two things. One is it stops the bridge from going sideways. Secondly, it stops that rubber from swelling outwards with the weight of the bridge on top of it. It traps it in place. If you look underneath the Sydney Harbour Bridge, we've got cast iron rocker bearings. Literally, that's sitting there bolted in place. And then as the bridge moves, just that rocks and rolls. So as that goes side to side, then that cast iron rocker bearing on what looks like a white cast iron plate. White cast iron because it doesn't wear out. Grey cast iron is the best to absorb vibration. One or the other, couldn't tell from looking at it. But it's a cast iron plate of some description, and that rocker bearing's just going sideways and letting the bridge swell. You actually need movable bearings on a bridge because between daytime and night time, the harbour bridge changes in length by that much. If you did not allow for movement, then the bridge would physically shrink and pull itself off the piers overnight. Modern bridges, Teflon plate on a Teflon plate. This is a modern moving bearing, just two Teflon plates, just rubbing across each other. Grey cast iron and grease is on the harbour bridge. Just a wear plate. It might even be white cast iron and white cast iron. White cast iron is brittle, but it does not wear, which is a great advantage because you don't really want to have to lift up a bridge to replace a cast iron pad. The modern bearings, however, modern fixed bearing, modern moving bearing. If I get the weight of a bridge, just put it on a block of polyurethane rubber, as I said earlier, it bellies out and it fails. It literally cracks because you've stretched it too far. How they stop it is they physically pour that rubber into a steel plate with holes all through it. Lots of steel plates. And those steel plates just stitch the bearing together. So instead of one big swell, there's just lots of tiny little swells that don't go past the failure limit. There's a steel plate, steel plate, steel plate, steel plate. That's bolted fixed to the pier. That's bolted to the bridge and moves. And that entire block might shear, so that might go like so. And that lets the entire bridge move backwards and forwards while the bearing's attached to both halves of the bridge, or the bridge and the pier. That's your bridge bearings.